Hello everyone, the topic of my presentation today is Student Achievement Prediction Model based on TLBO-BP. Now let's take a look at our talk chapter. The first part is a research background. The second part is correlation analysis. The third part is a TLBO-BP algorithm. The fourth part is the analysis of the results. Okay, let's look at the background. Why did we choose a topic of performance prediction? Today, educational prediction analysis has become an important tool for educational institutions to analyze students. And the performance of students in educational prediction analysis is a critical feedback. However, there are serious challenges in dealing with multi-factor datasets to improve the convergence and accuracy of predicting students' performance. Educational data mining and machine learning methods have become common tools to help students improve learning outcomes. Using EDM and ML techniques and methods to analyze large amounts of learning data has produced interesting and explainable information about the students. Next, let's take a look at the overall flow of our paper. We collect basic information about students through questionnaires. Activities related to achievement were screened by Pearson's correlation coefficient and a random forest classification method. We use BP neutral networks to make predictions about students' achievements. We use a TLBO algorithm to optimize the BP neutral network. Let's look at the second part, correlation analysis. When performing the correlation analysis, we used two methods, Pearson correlation and a random forest classification. Character selection is often an important step in the application machine learning methods. Description of modern datasets often contain too many variables to make it difficult to build actual methods. Usually, most of these variables are not related to the final outcome. Random forest is a typical feature selection algorithm that operates a characteristic importance evaluation mechanism while maintaining a better selection effect. The random forest classification algorithm by means of characteristic random substitution before and after error analysis calculates each characteristic's importance score. In the third part, we briefly introduce our predictive model. The principle of the TLBO algorithm differs from the relationship between teachers and students in an educational classroom environment. The effect of teachers on learners or students and the interaction between learners and their interactions. The teacher phrase and the learner phrase are the two main parts of algorithm, known respectively as the teacher phrase and learner phrase. BP network has higher non-linearity and a strong generalization ability. In order to improve the convergence speed of BP neutral network, we propose a method to optimize BP neutral network using teaching learning-based optimization algorithm. Finally, we analyze the results based on the random forest importance ranking and the personal correlation coefficient. We screen out 7 characteristics of community activities, tasks, experimental scores, tests, psychological scores, problems, and admission scores as important characteristic data. and reduce the complexity of follow-up algorithms through character selection methods. Based on the importance analysis of random forest classification and Pearson correlation coefficient, we found that community activities play an extremely important role in the final practical achievement. It can be seen from Figure 4 and Figure 5 that both training performance and testing performance are floating, which is different from the characteristics that the performance changes with the increase of training samples, indicating that the BP algorithm does not need too many training samples and is less affected by the number of samples in the performance prediction. In Figure 6, the BP neutral network is optimized by comparing different heuristic algorithms. We found that the BP neural network can be optimized by TLBO algorithm, GA algorithm, and ACO algorithm, but the TLBO algorithm can achieve faster optimization due to a small amount of hyperparameters and faster convergence. In this paper, we collect raw data by means of questionnaire. Feature extraction was performed using random forest classification and personal correlation coefficient to exclude features that were not re-entered to final score. The initial weights and thresholds in a BP neural network are optimized using TLBO-BP algorithm, which avoids the instability of training result caused by heuristic initialization and makes the full use of the advantages of the deep learning BP network and improves the prediction accuracy of the model. In the future, we should analyze the impact of different educational models on students and students' achievements. And it makes sense to collect the data through more accurate data collection methods to take advantage of the role of advanced technology in the field of modern education. Thank you for your watching.